Hey everybody, so let's go ahead and get started with our Unit 9 exam review. This is going to be on all things rational functions. This review should take you, on average, 2 days to go through. I think some of you will probably knock it out in one, but you will have at least 2 days of class time to go through this review. So let's go ahead and get started. So this first one says to simplify the expression and identify any restrictions. So what happens here is we have some division happening. So we've got this v plus 8 over v plus 4. Now, we have division. We know that when there's division, we are actually going to be multiplying by the inverse of this. So we're going to be flipping this equation around, or this rational expression around. So we're going to say v squared plus 2v minus 63 over v squared plus 17v plus 72. And so when we're multiplying this across, your brain should automatically start clicking, I have these trinomials here. I should really try to break these trinomials down into some binomials. So we're going to have v plus 8 over v plus 4 times, so in our numerator here, we're going to break this down to two binomials. To get v squared, that'd be v times v. I want two numbers added or subtracted that give me 2, but multiplied give me 63. Well, that would be a plus 9 and a negative 7. 9 minus 7 is 2, and 9 times negative 7 is a negative 63. In the denominator, we can break that down to two binomials as well. So in order to get v squared, we have v times v. Two numbers added or subtracted that give me 17, but multiplied give me 72. Well, that would be a plus 9 and a plus 8. 9 plus 8 is 17. 9 times 8 is 72. And so what we've done here is we've factored everything out, but now we need to start simplifying. So we want to find those binomial pairs. I have a v plus 8 here in the numerator, so this guy here, I can simplify them out with the v plus 8 in the denominator, right? That multiplication would result into a 1 happening there. It is important to know that that v plus 8 is going to cause a whole. So we're going to discuss that in just a bit. Okay. We also have the v plus 9 and a v plus 9 in the denominator. Those two would also be removable because that would cause a whole. And so what we're left with, and our final answer for the simplification, would be v minus 7 over v plus 4. But now, x cannot equal certain values. It cannot equal negative 4, right? Very simply, if I put a negative 4 in here, that would give me a vertical asymptote, right? We'd have a vertical asymptote at v equals negative 4. It can also not be negative 9. That negative 9 is what we removed here. We would actually have a whole at v equals negative 9. And x can also not be negative 8, because we would have this instance that we removed. We would have a whole at v equals negative 8. Okay. A lot covered in this question. I think this is a really good question to practice. Go through this video again if you have any issues, or send me a message and I'd be more than happy to help you out. So we do have to remember that when we're dividing, we have to really multiply by the reciprocal. We want to make sure that we're factoring anything that we can factor. Once we have everything factored, we want to see what we can simplify. And then we want to make sure that we identify not just the vertical asymptotes, which some students will do, but also all the wholes as well, as those values cannot exist. So you want to give that a shot here on this question. I'll tell you right now, there is division. So you're going to want to make sure that you multiply. And you're going to want to break down these trinomials into binomials. If you have any questions, let me know. Next part that we have here is identify any vertical asymptotes for the given function. So vertical asymptotes. Now, what I'm going to do is two ways of doing this. The first thing I'm going to do is I'm actually going to break down and factor what we see here. So in this numerator, in order to get x squared, we're going to have x times x. Two numbers added, they give us 5, but multiplied give us 6. So that would be a plus 3 and a plus 2. 3 plus 2 is 5. 3 times 2 is 6. Here in the denominator, our a value is a negative 3. So what I'm going to do is I'm going to go ahead and just simplify him out. And that leaves us with x squared plus 2x and then a negative 3. So I factored out that negative 3. And then so what that leads me to is I can still do a little bit more factoring in that denominator. So we still have x plus 3, x plus 2 here in the numerator over negative 3. And I'm going to break this denominator down to get x squared. Well, that would be x times x. Two numbers added or subtracted, they give us 2, but multiplied gives us negative 3. Well, that would be a plus 3, okay, and a negative 1. 3 minus 1 is 2. 3 times negative 1 is negative 3. And I'm sure you guys already seen that those x plus 3's would simplify out. So that would mean that we would have a whole at x plus 3 equals 0. So x equals negative 3. There's a whole here. Now the question isn't asking that, but I think that's good to practice anyway. What we're left with, okay, after we've simplified this out, is x plus 2 over negative 3 times x minus 1. That means that we take this final factor here, that x minus 1, set it equal to 0, and at x equals 1, we have a vertical asymptote. And this is how we would get that by hand. You could also use Desmos, plug in the entire equation the way it is, and we would see here that this line is at x equals 1. And this would be our vertical asymptote, right? This is a 1 here. So two ways of doing it. I really think it's important to practice the skill of simplifying and factoring, and then checking your work with Desmos, okay? Well, let's go ahead and move on to your problem. And so you have the same thing here. I will definitely help you out with this first initial factoring here in the numerator. If I factor out at 2, I'd be left with x squared minus 2x minus 3 over x squared minus 3x minus 4. So what you want to do here is you want to still break up that numerator into two binomials and the denominator into two binomials. See what simplifies out. Whatever factor is left in the denominator is probably going to be your vertical asymptote. Okay. Let's move on to the next topic. So identify the solution set for the inequality. These take quite a bit of work. Remember that your exam will be timed. Your best bet on this is to immediately start plugging these values into Desmos. And what happens here is on Desmos, it gives you these graphing sets. So we know that because we have these dashed lines here, okay, these dashed lines are going to cause us to go from negative 5 to negative 3 with a union of negative 2 to 5. Okay, and so those are the solution sets. I just went from here to here, here to here. Parentheses is when we have the dashed lines. That means that we're not including those values, but it's values within. And negative 2 to 5 is we are including those values of negative 2 and 5, so that's why we use the brackets there. Okay, just a bit of a review of inequalities. You've got the same situation here on this problem, so you're going to want to definitely put this into Desmos and work this out. If you have any questions, especially over the parentheses, brackets, all that good stuff, let me know. All right, so let's discuss transformations. So transformations here, it says the parent function f of x equals 1 over x undergoes these transformations to produce g of x. So if I have this f of x equals 1 over x. So the first thing I want to do is I want to have a reflection across the x-axis. So anytime we have a reflection, we know that we're immediately going to make this function negative. Okay, makes that negative. A horizontal stretch of 4. So that affects that a value, right? So that a value means that we're going to multiply by 4. So we're going to have now a negative 4 over x. We're going to have a translation of 2 units up. So that means that overall we need to add 2. And lastly, a translation of 3 units to the left. So that means that we would have to go x. Now we're going to the left. So a lot of students will want to put x minus 3. They think they go negative 3, but remember it's what our factor is. So it'd actually be an x plus 3 plus 2. And this would now be our g of x. Okay. So one step at a time. And just watch those transformations there. So now you're going to do the same thing here. So make sure that you identify every bit of transformation. Double check that work. Be very careful with that 4 units to the left. Okay. Again, if you have any questions, send me a message. Next, we want to simplify the expression and identify any restrictions. So with a question like this, really what they're just asking us to do is to simplify. Actually, we want to factor first. So we'd factor, if we can, simplify, right? And then after we have that, like what values can m not be? So we have addition here. So addition in this case, it gets a little interesting because we can't really add these two, okay? Because they don't have common denominators. So what we want to do is we want to identify those common denominators right away. Before I do that, I want to see, do we have any common factors? So we're going to go ahead and start simplifying things out. So I'm going to say 3m over, well, here in the denominator I see m squared plus m. I can factor out an m. And leaves me with m plus 1 plus 2m, and I'm going to break down this denominator into 2 binomials. In order to get m squared, that'd be m times m. I want 2 numbers added or subtracted to give me negative 6, but multiplied to give me 8. Well, that would be a negative 4 and a negative 2. Because negative 4 minus 2 is negative 6. Negative 4 times negative 2 is a positive 8. So we have all this happening here. Okay. I'm sure a lot of you guys are already seeing, hey, we can actually simplify out those m's because they are factors. So yeah, so we can actually simplify those out. We need to start making a list of what values m cannot be. So m cannot be 0. Even though we're simplifying them out, can't be 0. As soon as you eliminate them, yeah, you got to take them out of the equation. Okay, so then we're going to be left with 3 over m plus 1 plus 2m over m minus 4 times m minus 2. So if we want to start adding these, we need to have common denominators. So what I'm going to have to do is I'm going to have to multiply this first term here by 1. But my 1 will be m minus 4 times m minus 2 over m minus 4 m minus 2. Because I want to have these factors in this part as well. On this term here, well, I also want him to have an m plus 1, so I'm going to have to multiply him by an m plus 1 over m plus 1. So let's clean this up just a little bit here. So what we end up having is 3 times m minus 4, okay, times m minus 2 over m plus 1 m minus 4 m minus 2 plus 2m times m plus 1 over m minus 4, m minus 2, and m minus 1. So now we can add these up. And your final answer here, when we add these up, would be 3 m minus 4 over m minus 2 plus 2m m plus 1 over m plus 1 m minus 4 and m minus 2. And so you need to start seeing here that, well, m can't be negative 1 either, because that would make this 0. M can't be 4, and m can't be 2. So this is your simplified expression with your restrictions. And again, these restrictions are coming from these factors of what would cause either a vertical asymptote or this 0, which was going to cause a hole. Okay. All right, guys. Again, if you have any questions on this, send me a message. I'll be more than happy to help you. This should be day 2 of your work. So if you're already here, you're making a good pace. Let's go ahead and move on. This will be your problem. I'll tell you right now, you're gonna want to break down this trinomial into 2 binomials, and then do some factoring on this the second term here, and see how you can match up those denominators. Okay, let's go ahead and move on. So here you want to identify the removable discontinuity, the ordered pair of the whole. So the first thing we want to do is we want to start to factor. So I'm going to break this numerator into 2 binomials. Take it x squared, there'd be x times x. I want 2 numbers added, they give me 5, but multiplied give me 6, so that'd be 2 and 3. 2 plus 3 is 5, 2 times 3 is 6. Same thing in my denominator. I'm going to break this down. X squared would be x times x. 2 numbers added, they give me 3, but multiplied give me 2. That'd be a plus 2 and a plus 1. 2 plus 1 is 3. 2 times 1 is 2. So then you guys will see here that we can remove this x plus 2 and x plus 2. So this has already happened. Because that's happening, as soon as you start removing these binomial factors, you got to say, well, x plus 2 is going to give me a whole. So I'm going to set that equal to 0. I get that x equals negative 2, and there is my whole. We can take this one step further, and we can say that x plus 3 over x plus 1. And we can actually solve for your vertical asymptote by taking x plus 1, setting it equal to 0. We get x equals negative 1, and that's our vertical asymptote. So I know it's only asking for the removable discontinuity, that would be the whole, but just to be able to practice where we have our asymptotes, we can do that as well. So you'll do the same thing on this slide here. Okay, so you're going to want to factor the numerator, factor the denominator, simplify. Whatever gets simplified out, that's your removable discontinuity. Okay, let's go ahead and move on. So let's try this problem here. It says the time it takes to fill a tank T varies inversely. So as soon as I see this, I want to start coming up with an equation. So I know that T is going to vary inversely with the rate of a water hose R. Inversely, you recall, would be K over our value R. Okay? And then gives us some points here. So it says at 8 gallons per minute. So that's our rate. So our R is 8. The hose can fill the tank in 45 minutes. That means that T is 45. Okay? So typically, most equations or most problems would give us our K value, our constant of variation. But here they don't. They want us to solve for that constant of variation. So we need to solve for that. We're going to say 45 equals K over 8. So we just want to multiply both sides by 8. Okay, so 45 times 8 would give us a value of k is 360. So that means that our equation would be t equals 360 over r. And I'm going to box this not because it's our answer, because this is important. The next part says, how long will it take to fill the same tank at 15 gallons per minute? So that means that now we have an R value of 15. Well, if that's the case, we would say T equals 360 over 15. And we do this over 15 because R is now 15, so 360 divided by 15 is going to be 24. So this would take 24 minutes. So you recall when we do these inverse and direct variation problems, typically we probably will have to solve for that constant of variation once you have that you have your equation, and then you take whatever the next restriction is to solve for whatever variable they want you to solve for. So let's go ahead and move on to yours. You've got the same scenario, just different values. So if you need to go back to earlier parts of the video, please do so. Take your time. If you have any questions, let me know. And our last set of questions for the day says, the wind force F of a sail varies jointly. Okay, so we have F. It's going to equal some K, right? We already start writing our constant of variation. And it says jointly with the area A on a sail. So we're going to have times A. And the square. Okay, so this is new. They're going to say the square of the wind speed. So our wind speed needs to be squared. So we have F equals KAW squared. Okay, that's important. If it just said and the wind speed, well, you would just multiply, but it's the square of the wind speed. The force on the sail with an area of 500 feet squared. Okay, so they're already telling us that the area is equal to 500. And that the force, right, area is 500. The force is going to have to be 64.8. And a wind speed equals, right here, 18. So they give us the force, area, wind speed. We got to solve for K. So we got to put all this into our equation. So we're going to say 64.8, because that is the force, equals K times an area of 500 times a wind speed of 18 squared. Okay, so let's start kind of simplifying this a little bit. 64.8 equals K. So let's do 18 squared. Well, 18 squared is 324 times 500. Okay, that would mean that K times 162,000. Okay, we then want to divide both sides by this 162,000. Okay, so 64.8 divided by 162,000 is going to give us a K value of 0.0004. I'm going to underline that. That's important. Our equation here would mean that F equals 0.0004 times AW squared. So knowing this equation, they're going to tell us now that the area is 250. Okay, and a wind speed of 35. So they want us to solve for the force. So when we do that, we'd have F equals 0.0004 times an area of 250 times 35 squared. Okay. So let's go ahead and start doing that math there. We're going to say that f equals, and so 35 squared is 1,225 times 250, and then times 0.0004, we would get a force of 122.5. And there's your answer. So I apologize, I got a little squashed here, kind of ran out of room, but I think you guys get the gist of it there. So same idea, except, well, same idea as the last problem, except now we had a little bit of joint variation as well. This could go with compound. If you have compound, you just really need to follow, like, what are they expecting here? Okay. You guys will have the same type of problem. Nothing changes except for the values. So you're going to want to get all your identifiers, all your variables, solve for your constant of variation. Once you have that, you can create your new equation and then solve for the missing variable. Again, guys, throughout any part of this review, if you have any questions or concerns, send me a message on Teams, and I'll be more than happy to help you guys out. Have a good one, everybody.